Alright, so this lesson is going to be on solving navigation problems. So this is the next step up from what we were doing yesterday. There's a warm-up here. An airplane is flying 2 miles above the ground. The angle of depression to the airport is 22 degrees. What is the ground distance to the airport? So if you want to go ahead and pause the video and work through that problem, you can go ahead and do that. So what we have is an airplane. It says it's 2 miles above the ground. So this distance here would be 2. And I have an angle of depression of 22 degrees. So an angle of depression is from the horizon. So I have a horizontal line here, and this angle of depression is right here. So that's what the 22 degrees is. A lot of people make a mistake and think it's right here, when really it's on the outside of that triangle. The nice thing about that, though, is the angle of depression always equals the angle of elevation because of the alternate interior angles. So I know that this also is 22 degrees. And if I'm looking for x, this distance here, the distance from the airplane to the airport, all I have to do is tangent of 22 degrees equals opposite over adjacent. So it's going to be tan 22 equals 2 over x. Multiply by x on both sides. We've seen this done. So you get x tangent 22 equals 2, and then just divide by the tangent of 22. And then you would plug this into your calculator. Make sure it's in degree mode. So I'll pull that up. So 2 over tangent of 22, and you get 4.95. And that's miles. So that would be your final answer. So that's just a quick review of the easier types of problems we were doing yesterday. So today we're introducing, let's get rid of this. Headings and bearings. So when you see an angle given to you, a direction given to you in a heading or a bearing, that's from north. So rather than starting here at the positive x-axis, we're going to start here at 0. So if you had a heading of, let's just say 150 degrees, you're going to go 90, 150. Oops. And then this would be that heading or bearing of 150 degrees. Now the important thing to remember here is this last part here. We still want to find the angles with respect to the x-axis. So I'm still going to, once I find where it is, I'm still going to refer to it in terms of its reference angle. So although this is 150, I'm going to find the difference between 150 and 90, which is 60 degrees, and that's what I'm going to use as that angle, that 60 degrees. So even though now I'm going from north clockwise to find where the angle is, to find what direction it's going in, I still am going to refer to the reference angle when doing any type of calculations. Alright, so we can look at our first example. An airplane takes off and flies at a compass heading of 100 degrees for 80 miles. So I'm going to start off, I'm just going to put in a little diagram so that I can see what's going on. So I'm just going to put an axis just to reference, and it's going at a heading of 100. So remember, this is 0 now, this is going to be 90. So a bearing of 100 is going to be right there. This here is 100 degrees. But remember, I want to know what that reference angle is. So really, I want to know that this is the difference between 90 and 100, which is just 10. So that angle there is going to have a reference angle of 10. and it says it goes on that heading for 80 miles. So this distance here is 80. Go a little longer. So now this is where the airplane is. It then says that it has to change its heading to 190 degrees. So once it said I'm getting my second heading, I'm going to go ahead and draw a second axis there, and then essentially start over with this second part. So this is going at a heading of 190. So again, here's 0, I have 90, this here is 180. So 190 is going to go all the way around to right here. I suppose that'll be a little smaller because it's only 25. So it does that for 25 miles to avoid a flock of birds or something like that. Alright, so if that's 180, if that's 190, that bearing, again, I still want to know what my reference angle is. So this angle here, if this is 190, this is 270, the difference between 190 and 270 is 80. And if you notice here, I can also find this angle here because it's an alternate interior angle of this 10 here. That's just like the angle of depression, angle of elevation. So I also know that this angle here will be 10, and 10 plus 80 is 90, which is very helpful because that tells me that this here is a 90-degree angle, which is what I need in order to do my right triangle trig that we've been doing. So ultimately what the question asks is what is the distance in heading from the airport? So I'm trying to find, let's see, the distance. I'll skip over the 80. This distance here, I know that this is 80, as I wrote before, and that this here is 20. And it's a right triangle, and then I want to find the heading, which means from north, from 0 to that terminal side. So to find this third side here, well, let's just call it C. It's really quite easy because it's just Pythagorean theorem. So I would do a squared plus b squared equals c squared, and then I'd solve for it that way. So to find the third side, that's all I'm going to do. So I have 80 squared plus, that distance is 25 squared equals c squared. Let's go back and fix that. This here should be 25. So I'll go through 80 squared plus 25 squared. Take the square root of that. And that'll give me my distance from the airport. So I get 83.8 equals C. So that's the distance from the airport. So that answers my first question. The second question is the heading. So what I'm going to do is I'm going to work to find this angle in here, this small angle in here. And if we think about this angle in terms of trig, I have an angle we'll call theta. That's what I want to find. And it looks like I know my opposite side is 25. And I know my adjacent side is 80. So I know that that's the tangent function. So what I can do is inverse tangent of my opposite over my adjacent, and that'll give me theta, which is that angle in there. So let's scroll down a little bit. So again, this is tangent of my opposite side of that little angle there, 25, over the adjacent side, which is 80. Make sure I'm in degree mode. Second tangent, 25 over 80, and you get 17.4, we'll call it. But we have to be careful because theta is just this distance here. So what I want to do is add that 17.4. If I add it to this original heading in the red there, which was 100 degrees, that'll give me my heading from north, because that 17.4 is just that little blue area right here. So I need to know from north all the way to here. So I add 100 and I get 117.4 degrees. I'll just write from north. So that is my heading, and this is the distance, 83.8 miles. Alright, so I know these problems are pretty involved, but after you do a couple of them, you should start to get the hang of it. So we can look at another one here. A squirrel on a remote controlled hovercraft is sent on a heading of 330 degrees for 75 yards. So I'm going to go back, start with my, let's see, 330 degree yards. Let's make this, start this one a little lower. So the squirrel on a remote controlled hovercraft, 330 yards. This is 0, so that's 90, 180, 270. 330 is going to be right here, so that's that distance there. Oops, I'm sorry. From north here to there, that's 330. This is 270. And then from that point, it tells me that the hovercraft then changes direction and goes due south, stopping when the squirrel is due west of the starting point. So that tells me it's going to go due south, straight down, and it stops when it's due west of the starting point, which was right here. So again, I'm given a right angle. So this distance here was 75. So this distance here is 75, and so right now that looks to be the only piece of information I have, but if I go back, I remember that this here was 330, this angle is 270, 330 minus 270, that'll give me this reference angle, which is going to be 60. Now I can solve for this length here. It asks how far is the squirrel from the starting location, that's just x. So now I have an angle theta, which is 60 degrees, I have my hypotenuse, which is 75, and I'm looking for my adjacent, which is x. So that's going to be the cosine function. So all I do here is cosine 60 equals adjacent over hypotenuse, multiply by 75 on both sides. So I get 75 cosine 60 equals x. 75 cosine 60, and I get 37.5. And that would be yards. And the reason we're not asked for the heading here is because it's exactly 270 degrees, it's right on the axis. But again, I didn't use that 330 degrees, I used the reference angle of 60 degrees for my triangle. So here's another one very similar to the first one, so why don't you go ahead and pause the video and see what you can come up with for this. So they give us that a ship is traveling at 30 knots from its home port on a course of 105 degrees. So 30 knots from its home port on a course of 105 degrees for 5 hours. So 105 degrees, again this is 90, so 105 is going to be right here. I know that's not perfect to scale. And now here, this is a little tricky because it tells me 30 knots for 5 hours. So that tells me a speed and a time. We know distance equals speed times time, so I can just do 30 times 5, and that tells me that the ship went 150 nautical miles or whatever you want, whatever the measurement would be. And then it tells me it has to change course. So now from this new point, well, I'll go back and talk about this angle real quick. If this distance here is 105 and this is 90, then this here must be 15, because 105 minus 90 is 15 degrees. So now it changes course to 195. So this is 0, 90, 180 is right here. So 180, 195 is going to be right here. That's your 195 degree heading. And here it says for 2 hours, so 2 times 30 is going to be 60. So that's that distance there. So here's the resulting distance that it's gone from the starting point to here. And that's what I want to solve for. So it asks find the distance and bearing from home port. So the first thing I can do, again, very easily, if this is 15, this is 15. If this here is 15, because 195 minus 180 is 15, then I know that this must be 75, because 270 minus 195 is 75. So again, wouldn't you know, I have a right triangle there. It's going to happen every time. So I can find the third side of my right triangle, which is the distance, by doing Pythagorean theorem. So that's 150 squared plus 60 squared equals c squared. So 150 squared, 150 squared plus 60 squared. Take the square root of that, and you get 161.5. So that is, not what I wanted to do. $161.5, I'll just write km for nautical miles, is c. So that's the distance from home port. And now again, I want to find my bearing. So in order to find the bearing, is a two-step process. I'm first going to find this angle using inverse tangent, and then I'm going to add that angle to this original bearing of 105 to get this distance here. So to find that, I have my, again, theta on my opposite side of 60, my adjacent side of 150. So I can do inverse tangent of opposite over adjacent, and that's going to give me theta. So inverse tangent 60 over 150, and I get 21.8. But remember, that's just this angle here, so I need to add it to the original distance, the original heading, which was 105. So I would get 126.8 degrees from north. So again, I know these problems are fairly complicated, but as you can see, this is almost identical to the first problem. So that should be helpful, that they're repetitive. Alright, go ahead and try this one on your own, and then I will solve it. Alright, so here's what I came up with. I first graphed the scenario. Here's the heading of 115 for 3 miles. Then they change heading of 205. Again, we see we get a right triangle here. Heading of 205 for 4 miles. I could solve the third side very easily. It's Pythagorean theorem. Get 5, and then I just did inverse tangent of opposite over adjacent, 4 over 3, to get theta. And then I had to add 115 to theta to get this angle here. Alright, so hopefully this was helpful for you guys. I know this may be a little overwhelming at first, but again, after we do some example problems in class tomorrow, I think you'll feel pretty confident about it.